question 5, the trigonometry section of this paper. And question 5 says 5.1, given that the square root of 13 sine x plus 3 is equal to 0, where x is an element of 90 to 270 degrees, without a calculator, determine the value of the following. Okay, so we have to find the value of the following. So as you can see from the information that they give you, we have a trig diagram, okay, because it's really hinting at what x is and where x is and where our diagram is really. So let's go ahead and sort that part out first. We are given the square root of 13 sine x plus 3 is equal to 0. Okay, so with this, let us leave sine x on its own so that we can find out what sine is. So the square root of 13 sine x is equal to negative 3. And then we'll divide both sides by the square root of 13 to get sine x alone. So it means that sine x is just equal to negative 3 over the square root of 13. Okay, so now that we have this, we can use this to draw the diagram down. So with our diagram, let's figure out where exactly this terminal arm is going to lie. We are told that sine x is equal to negative 3 over the square root of 13. So sine is negative. So think about the quadrants where sine will be negative. Okay, so this is where all is positive, and then S, T, and C, right? So the places where sine is negative would be in tan and cos. But then this says that x is going to go from 90 degrees to 270 degrees. When you mark your angles, okay, starts at 0, 90, 180, 270, and then 360. So marking all the quadrants from 90 to 270 would be from 90 degrees to 270. So that is the second and the third quadrant. And so you're just going to pick the quadrant with the most ticks, which is the third quadrant. So our terminal arm lies in the third quadrant. Okay, so it will look like that. And then we just draw the arm. So it goes down, and then let's just put down what would be here. So this goes up to the x-axis, and it's always perpendicular to the x-axis. And the x that we're looking at, that angle, is drawn from here all the way to there. So that is x that we'll have. And we can put these down now. All we know is that sine of x is equal to negative 3 over the square root of 13. Now you know that sine is opposite over hypotenuse. So definitely a hypotenuse cannot be negative. So this negative is definitely going to go to the 3. So the opposite side, opposite of this angle, is going to be negative 3. So that's where the negative 3 goes. And then the hypotenuse is the square root of 13. So we only have to find the adjacent side. So let's go ahead and find it. So that is an x value. So we're saying, well, we can just call it something else just because we have x as the reference angle. So let's just call it a for adjacent. So a squared is equal to, and we're going to say, and we're going to take the hypotenuse squared, okay, and then minus by the other shorter side, which is negative 3 and squared. Okay, so a squared is equal to, that's 13 minus, that gives you 9. So 13 minus 9 gives you 4. So a squared is equal to 4. And then when you square root both sides, a is therefore equal to 2. So positive or negative 2 really, because it's the adjacent side. But based on the diagram, we'll be able to tell what it is. So do you see where this 2 is? It's going from this hand side all the way to this side. It is on the left hand side of the x-axis. So it's the negative part of it. So it means that this is actually negative 2 and not just 2. So a is equal to negative 2. And there we go. So we have all of this now. And now we can use the information that we have to answer the questions. The first question is to find sine 360 plus x. Okay, so sine 360 degrees plus x. This is one of those ones that confuse people. When you see plus x, then it kind of looks like the 360 minus x. It's not the same thing. So here's the thing with angles. If you have an angle and you notice that it is greater than 360 degrees, what you will do is subtract 360. So greater than 360, just subtract by 360 degrees, okay? And if you have an angle that is negative, okay, so negative angles less than 0, you will add 360 degrees, okay? So with this angle, you have 360 degrees plus x. You already have 360 degrees, and then you add in an angle to it. So it's going to be over 360. So just subtract 360 degrees from it. And that, if you subtract 360 degrees, it really just gives you sine x. So what is sine x? Well, we actually told, yes, we were. Sine x was negative 3 over the square root of 13. So that is our answer, and we're just going to put that down. So sine x is equal to negative 3 over the square root of 13. And that's our answer there. Okay, moving on to the next question. Okay, so the next question, 5.1.2, is we have to find the value of tan x. So with tan x, you just have to remember saw, ka, toa, with all of these really. And so tan is opposite over adjacent. So we're going to take the opposite over the adjacent side. The opposite side is negative 3. Adjacent is negative 2. So you have negative 3 over negative 2, which really just gives you positive 3 over 2. And that is our answer there. Moving on to the next question. The next question is cos 180 degrees plus x. In your reduction, 180 degrees plus x appears in tan's quadrant. So it means that this would be reduced to negative cos x. And then you just have to find that. What is cos x? So cos is adjacent over hypotenuse. So we're taking the adjacent side over the hypotenuse. So negative 2 over the square root of 13. So remember, this negative is still there. And then negative 2 over the square root of 13, which just gives you positive 2 over the square root of 13. And there is our answer. Okay, so in these, I won't put them on the calculator because the calculator will rationalize the denominator. And you see that they said without using the calculator. So I'll just leave it like that. So that is it for question 5's first questions. And we move on to the next question. Question 5.2 says, determine the value of the following expression without using a calculator. So with this expression, we're just going to really do whatever we need to do on the expression. In the numerator, you have cos 90 degrees plus theta. That is cofunction. So we have to use cofunctions there. So the cofunction of cos 90 degrees plus theta, as shown on the screen right now, is negative sine theta. Okay, that's the only one that becomes negative, the one with the cos and plus. Okay, so we have that over, and our denominator, do you see what we have here? We have sine theta minus 180 degrees. Okay, you have a negative angle. The minute you see your angle is negative, overall this is actually negative because theta would be seen as an acute angle. And so if you take an acute minus 180, you're going to get a negative angle. So when you see the angle is negative, what should you do? You need to add 360 degrees to that. You don't even have to show them, you just show them the result of it. So this will now become, if you add 360 to negative 180, you're going to get a positive 180 degrees, and then plus theta. And then we have plus 3 sine, and we have negative theta. The angle here is negative, so what must you do? You need to add 360 degrees to it. So that's going to be 360 degrees minus theta. And now you can just go ahead and reduce. So it's equal to negative sine theta over, and let's reduce there. So that is in tan's quadrant. It's going to become negative sine theta. And then this is in cos's quadrant, but the function is sine. So that's going to become negative. But you see that you have a 3 here. So that negative that's supposed to go to the sine theta, right? You can put it in front of the 3 because it really just multiplies to the positive 3. So that becomes negative sine theta and multiplies, because it's next to it, to that positive 3. So it's giving you negative 3 sine theta. Okay, so whole lot of sine thetas. What we can do is leave negative sine theta on the numerator, but on the denominator, you don't have to take out a common factor because it's not really a common factor situation. These are like terms actually. It's negative sine theta minus 3 sine theta. It's like having negative x minus 3x, which is negative 4x. So in the same way, this is negative 4 sine theta. And now we can finally simplify this. So this is equal to, these will cancel, this sine theta and sine theta cancel. The negative and negative is gone. So what do you have on the numerator now? you have an invisible 1, because what happens is these are really just dividing by themselves, like sine theta divided by sine theta on the top and the bottom. Okay, so 1 over, and the denominator that's left is 4. So there we go. 1 over 4 is our answer there. And we move on to 5.3. The next question, 5.3, says, determine the general solution of the following equation. Okay, they've been very nice here. They factorized it for you. So you just have to solve. So since they factorized it, you have something times another thing gives you 0. Therefore, it means the first factor, cos x plus 2 sine x, is either equal to 0, or the second factor, 3 sine 2x minus 1, is equal to 0. Okay, so now we can just work on them. Okay, so let's go ahead and solve. So we're going to leave sine x here is equal to, and when that goes over, it becomes negative cos x. Then we need to form tan, like we said. So to form tan, you're going to have to divide both hand sides by cos, because you want to make it sine over cos. So over cos x on both sides, because it's an equation. But here's something that we need to now take into account. You want tan x to be left here alone. Okay, tan x must be equal to some number. So 2 needs to go as well. So we might as well divide both sides by 2 as well. Okay, so this now is equal to tan x, because the 2's are gone. And then here the cos is gone, and you have negative and then over 2. So it's really negative 1 over 2 is equal to negative 1 over 2. And we just have to find the general solution for this. Now, with this equation, I have a video on this, and I show you how we can solve for these equations in a quicker way, okay, that still gets you to the same answer. But please note that in the tan section, right, there's a place where I say plus 360 degrees, because I was still following the sine and the cos graph and how they go. It shouldn't be plus 360 degrees, okay, it should be plus 180 degrees that you add, because the tan graph will repeat itself every 180 degrees. So for the sake of understanding, let's go ahead and use that quick method over here, and instead of the quadrant method, okay, so that you can understand what I mean by plus 180 degrees. Okay, so here's what we have. With a quick method, you don't have to consider whether your number is positive or negative. We don't care about that. All we're going to do is go ahead and find the reference angle, and we'll find it by taking tan over. So we'll say shift tan of negative a half. Okay, but we don't have to write that down. Okay, so shift tan and negative a half, shift tan of negative 1 over 2. And what do we get? We get a negative angle, which is fine. Negative 26 point. And I'll round off here. The reason I'm going to round off is because, do you see that this is tan of x? It's not tan of 2x. So I don't have to divide later on at the end of the day. So this is fine. We can leave it like this. And now we can go ahead and solve. So with your method, you'd probably think about the Cartesian plane and then say, where is tan negative? You know, but you wouldn't have even said shift tan of negative a half. You would have said shift tan of positive a half. With a quick method, you don't have to consider whether it's negative or positive. You just take it like that, okay? As negative if it's negative, positive if it's positive. But then you don't have to consider the Cartesian plane either. With a quick method, you just have to remember that for tan, it's always going to be theta is equal to whatever your reference angle is plus k of 180 degrees. And then if your angle is negative, okay, and this is what I made a mistake in that video. I followed the sine and the cos graph and how they work. If your angle is negative at the end of the day, all you will do to make it positive is add the angle that it takes to repeat itself, that graph takes to repeat itself. So in this case, we'll just add 180 degrees. Okay, so here our answer for x is equal to, and we'll say it is negative 26.57 degrees, but it's negative. So you want to make it positive so that it looks like the answer that the memo will give you. Okay, so plus you would say 180 degrees, and then because this is a general solution, we'll say plus k of 180 degrees. Okay, I'll tell them where k is an element of integers at the end. Okay, we can tell them k is an element of integers here just so that we don't forget. Okay, so let's just solve for that. What is 180 degrees plus that? Just take this answer and then add 180 degrees to it. And that's all. So the answer is x is equal to 153.43 degrees plus k of 180 degrees. And that's really all you have to do. Now I know with yours, you would have two solutions. But the thing is, the second solution does not need to be there. The solution with a bigger value, it doesn't have to be there. Here's why. It's because of the way the tan graph works. With the tan graph, okay, it goes up, then it's an asymptote, and then it goes like that, and then it just continues doing that, okay? It goes up again, asymptote, and then continues like that, okay? So this would be at 180 degrees. This graph will repeat itself every 180 degrees. So you don't actually have to rewrite that second case scenario. The second case scenario would have been, let's just pretend this was positive, because it's just going to make more sense if we pretend this was positive. Here's what I mean by this. The reason you don't have to write the second solution. Remember that in the first quadrant you have theta. And what we've really just done is written down the reduction for theta. We just said x is equal to whatever our answer is plus k of 180 degrees. The only reason we added 180 degrees here was just to make it positive so that it looks like the answer that we would have, for example, in the memo. But the other place that tan is positive is here in 180 degrees plus theta. Okay, so you took already what your reference angle was, and then they're just adding 180 degrees to it. So your second answer would be 153.43 plus 180 degrees. It will look like this, like that, with that number. But here's the thing, it is not really necessary. You can put it down if you want to, but it's really not necessary. And the reason I say so is because this graph will repeat itself every 180 degrees. You've already said that with k. So you now taking this and then also putting down this answer of 333 degrees is a little redundant. It's just a little repetitive because of course it's going to at some point equal 333 degrees. We're adding 180 degrees every time. That's why we have k of 180 degrees. So this is the general solution. You don't need the other one with tan only. Okay, and it's really just because of the way the tan graph looks like that. Okay, and just adds 180 degrees every time. With the cos and the sine graph, they're a little different. Okay, for example, the cos graph that looks like that, you see there is that bump where you have two solutions within one specific interval of k. For example, let's say k was equal to 1. You can actually have two solutions in that interval. Unlike the tan graph, okay, when you get an answer here, the next answer is just whatever that is 180 degrees later, done. So this answer is just going to repeat itself, so you don't really need that. Okay, so that is it for that part. We're not yet done, so I have to solve for the other equation. So this is the second equation that we have. Let's go ahead and solve. We need to solve for x. So we've got 3 sine of 2x minus 1. So we can say 3 sine 2x is equal to 1. Then divide both hand sides by 3 to get sine 2x on its own. And this is equal to 1 over 3. And then now we can find our reference angle. So with this one, be careful because you have 2x, meaning whatever x is, you're going to have to divide by 2 at the end of the day. So let's go ahead and find the reference angle. What is shift sine 1 over 3? So we'll say shift sine of 1 over 3. And you see what it gives us. So we'll keep that answer. And it is 19.47. Okay, so your answer and your work in here is really just going to be like mine as well. With the quick method, when it is sine, all you remember is that your answer for theta is going to be whatever your reference angle is. And then you're going to say plus k of 360 degrees, and that's the first solution. And then the second solution would be 180 degrees minus whatever your reference angle is, plus k 360 degrees. And then you don't even bother on whether it's positive or negative. You just stick with that as the solution. So you can watch that video to see what I mean by that. Okay, Now, with this, there is no need to round off. I don't know why I'm rounding off. Shouldn't be rounded off. So I'm just going to leave it as 4712, just so that it shows that I have not rounded off yet. We'll hold on to that. Let's go ahead and solve for our angle. So first we solve for the angle before we actually get to x. The angle that we have is 2x. So we're saying that 2x is equal to, again, you're going to just say your reference angle, which is currently 19.4712, and then you just say plus k of the amount of angles that it takes for this graph to repeat itself. The sine graph repeats itself every 360 degrees. So plus k of 360 degrees. Of course, where k is an element of integers. We can just write it for both, it's fine. Okay, so that, or, okay, so I'm just going to put the second solution. So 2x is equal to, and then you'll take 180 degrees minus your reference angle, which is 19.4712, and then plus k of 360 degrees. Okay, so let's go ahead and solve for the first one. You see, with this, all you have to do is finally solve for x. So you see the 2 is in the way. We need to divide both hand sides by 2. And so therefore, x here is equal to this answer divided by 2. Okay, which gives you 9 points, and now you can round off. So this is going to be 9.74 degrees. So 9.74 degrees plus k of 360 divided by 2 is 180 degrees. Okay, so we're done with that one. Then we're here. So you first have to say 180 degrees minus the 19.47. So you can remove that 2 so that you have this, and then say 180 degrees minus that number. Okay, shift sign of 1 over 3, because that is the 19.47 that we have there. So 2x, first of all, is equal to, we're just solving for that first. It's 160.528. Again, I'm not rounding off yet. Then I still say plus k of 360 degrees. And now we can divide. So divide both hand sides by 2 to get rid of the 2. Therefore, x is equal to, and we're going to take that whole answer, right? And you're going to say the answer divided by, you can use the answer button. You press AC and then say answer divided by 2. And our answer is 180 points. And now we can round off 26 degrees. Okay, and again here, that 360 divides by 2 to give you k of 180 degrees. Okay, where k is an element of integers there. And there, of course, as well. So those are our solutions. Okay, so our solutions are this, this, and finally this. Okay, so that is the general solution. Moving on to the next question. We are on 5.4, and it says, given the identity cos x plus y multiplied by cos x minus y is equal to 1 minus sine squared x minus sine squared y. And we have to prove this identity. Okay, so deciding on the hand side that we're going to use, you see that with the left hand side, we can actually expand here. Okay, and then these are still multiplying. So we're definitely going to use the left hand side. With the right hand side, there's not much that you can actually simplify. I mean, you can. It's just really not going to make that big of a difference. Okay, we are going with the left hand side, and we're just going to rewrite it first. Okay, so with the left hand side, we'll say it's equal to, and you see that these two are multiplied. But we can use compound angles to expand that. So that's going to be cos x cos y, and then because it's a plus, it changes to a minus sine x sine y. And then this gets multiplied by, since we have two terms, we can just multiply using brackets. This gets multiplied by this, which is going to be cos x cos y, and because it's a minus, it becomes a plus here, and we have sine x sine y. Okay, so they're multiplying, so we have to FOIL it out. Definitely something is going to cancel because they're exactly the same, as you can see, but we have a minus and a plus. So you're going to have a term, two terms that will cancel. But let's go ahead and multiply. If you multiply the first term with the first term, you're going to get cos squared x, cos squared y, and then that's it. And then the first term with the second term, As you can see, nothing there is the same. So it's just going to be, I'll start with the sign. So plus, let's just put it, that's probably the thing that's going to cancel because it's positive and then it's negative. Okay, so positive sine x sine y, and then we're multiplying this by, and then we're multiplying by that. That's cos x cos y. Okay, and then it's these two that multiply. Okay, again, so that's minus sine x sine y cos x cos y. As you can see, they're exactly the same, but just the positive and the negative. And then the last terms would be these two that multiply, which gives you negative sine squared x sine squared y. Okay, so these two are going to cancel, and then we are left with cos squared x cos squared y minus sine squared x sine squared y. Okay, so now that we have this, we can compare it to what it should be equal to. Let's just see what we need to simplify. Okay, so when we compare these two together, right, this and this has three terms, 1, 2, and 3, right? And this has two terms only. But I see a sine squared and a sine squared x and a sine squared y. However, it's not really the same type right now because these two are actually together. But let's try to leave them. Let's just leave them. This is really just a trial and error thing at this point. And now, to be able to get a 1, you probably had the identity sine, squared x plus cos squared x, or it may even be sine squared y plus cos squared y. But we can't force it to be there. So here's what we can do. We can change any of these two so that we can, create 3 terms, because it's 2 terms right now. It should be more than 1. So with these, right, cos squared y and cos squared x, they can create 2 terms. Remember the identity sine squared x plus cos squared x, that this is equal to 1, okay, because it's a sine and cos. So with this, you can change cos squared x into 1 minus sine squared x. So that's what I'm going to do. I'm going to go ahead and change cos squared x. So change that, and now it is 1 minus sine squared x. But then remember that this is still being multiplied to this. So you see, you have 2 terms here now. That's great, because when it multiplies with this one, you're now going to have 2 separate terms here, and then this is the 3rd term. But let's just see how it works out. So cos squared y, then minus sine squared x times sine squared y. Okay, so we'll have to distribute here. So 1 times that stays exactly the same. So it's cos squared y, then times that is negative sine squared x cos squared y, and then this stays exactly the same. Now it's starting to actually look okay, like we can actually do something here with this. So we have 3 terms, great, but we need to have this at the end of the day. So it needs to have a separate sine squared x and a separate sine squared y. Now look at these two. If you group them together, do you see they have something in common? So we still have cos squared y, but these two, they have negative sine squared x in common. Then you'll be left with the cos squared y and the sine squared y, which can add up and give you 1. So that gives you negative. We have minus sine squared x. Then open bracket, what is left here? Okay, you took out the negative sine squared x, so you only have cos squared y left. Same thing here, you took out a negative. Okay, so when you divide, that negative is now gone, and you're left with positive sine squared y. Okay, these together give you 1, so you can rewrite them, and then in place of cos squared y plus sine squared y, we can say that that is equal to 1. So this gives us 1. Okay, so it just stays exactly the same. So really all we have is cos squared y minus sine squared x. Okay, how can we get this to look like this? We're not that far off anymore, because do you see that this has 3 terms, and one of the terms that it has is minus sine squared x, which is also what we have, minus sine squared x. So the other term is 1 minus sine squared y. You have a cos squared y here, so you can change that using the identity of cos squared y. The identity of cos squared y would be 1 minus sine squared y. And then you have minus sine squared y. And that's actually how we get that. So you see, it is 1 minus sine squared x minus sine squared y. And if you like, you can just put them in the same order. 1 minus sine squared x minus sine squared y, which is therefore equal to the right-hand side. So there we go. So it was just distribute, cancel where it needed to cancel, and then change one of those to the identities. Okay. You could have also changed this one as well, so it probably just worked out the same way. So that is that answer. Moving on to the next question. The next question, 5.4.2 says, hence, determine the value of 1 minus, okay, so same thing that they gave us, right? 45 degrees minus sine squared 15 degrees. Okay, so you see it's in the same format. So if this, right, was the identity for this, then it means that you can just put that in place of it. Okay, so this would also be equal to, you're kind of going to view the 45 degrees as your x and that as your y. So this is the x, this is the y. So if this was equal to the right hand side, you can make it equal to the left hand side, because without using a calculator, you can't really just substitute. It's not going to work. So let's use the left hand side. The left hand side looked like this. We're just going to substitute in place of x and y, and we'll be able to find this. So since we knew about that, right, it means that this one is actually equal to cos, and in place of x, we're going to say 45 degrees, and then plus y, which is 15 degrees. So plus 15 degrees, and then multiply by cos of 45 degrees, again, minus 15 degrees, minus 15 degrees. Okay, let's go ahead and simplify. So with this, you don't have to use compound angles, because you see these are special angles already. 45 degrees plus 15 degrees is 60 degrees. What is cos 60 degrees? Okay, multiplied by 45 minus 15 is 30, so cos 30 degrees. Okay, so we can actually find this. Cos of 60 degrees using the circle, the triangles, or using the OHA rule, which I have explained before. Okay, cos of 60 degrees will be, so I can just put down the OHA rule here so that you guys can remember. So it goes like this, OHA, and then you say 30 degrees, 60 degrees, and 45 degrees. You use this when, you know, you're not supposed to use a calculator, because they would know. But in this one, they wouldn't, because they're using safe angles like 30 and 60, okay? I'm just trying to remind you of how this rule looks. So 30, 60, 45, OHA, and then you say 1, 2, 3, 3, 2, 1, and 1, 2, 1. Then in each row, you're going to square root the biggest number. So the biggest number here is 3, biggest number here is 3, biggest number here is 2. And so to find cos 60, remember that cos is ka in SOHCAHTOA, so it's adjacent over hypotenuse. We're going to go to 60 degrees and take the adjacent over the hypotenuse, and that's how we know it's a half. Then multiply by cos of 30 degrees. So again, it's ka adjacent over hypotenuse is going to be adjacent over hypotenuse, which is root 3 over 2. And so if you multiply these together, that's going to give you root 3 over 4. And there we go. So that's our answer. So that's what I mean by these are the safe ones. You wouldn't need the OHA rule for this. If you use the calculator, nobody would have known. Okay, but it's good to keep these, you know, for situations where you're not allowed to use a calculator at all. Okay, so that is it for that question. And then we move on to question 5.5. Okay, 5.5 says, consider the trigonometric expression, and we are given, so might as well just rewrite. They say rewrite the expression as a single trigonometric ratio. Okay, so we have 16 sine x times cos cubed x, okay? Things that we don't really want to be there, but we'll take them out. So 8 sine x cos x. So the first thing that we already see is that we have two terms. And since we have two terms, and that's really just it, we can factorize this. The first type of factorization we can perform on this is taking out a common factor. So what is the highest common factor between these two terms? Well, with the 16 and the 8, it is 8. With the sine x and sine x, it's just sine x. And with the cos cubed x and the cos x, it's cos x. And what is left? That's going to be, when those divide, it's 2. Those divide, they cancel. And when these divide, it is cos squared x. And with this one, it's just minus 1 because it's the exact same thing. Okay, let's see how we can take this further. So I know this is a double angle, so we can change that to cos 2x. And then this one. Okay, this one is a double angle if we write it correctly. So look at how we can rewrite this. So you're going to separate the 2 from the 8. So 8 divided by 2 is 4. So you're going to have 4 multiplied by 2 sine x cos x. And then you see how they'll change. So this one will change to cos 2x. And this one, as you can see, that is a double angle expansion for sine 2x. So this is equal to 4 multiplied by sine 2x times cos 2x. Okay, so you see what we have now. Now, do you see that these are in the form of sine of an angle, cos of an angle? That's again double angles because you have the exact same angle. So we could break that 4 apart into 2 multiplied by 2. So what you have is 2 times 2 sine 2x cos 2x. Okay, we've expanded it to that. And so because of that, you see that this is the same thing as sine 2 sine a cos a, right? So that is double angles that we're going to use to simplify that. It is going to be sine 2a. But our 2a is 2x. Our a this time is 2x. So this is equal to 2 multiplied by, and this is sine 2 times 2x, which is 4x. And yeah, that's what it gets to. 2 sine 4x. And that is our answer. Okay, simplified to a trig ratio, and that is it. Moving on to the last question in question 5. Okay, the last question for question 5 says, for which value of x in the interval where x is an element of 0 to 90 degrees will 16 sine x cos, okay, yeah. So where will that have its minimum value? Okay, we must think about this question carefully because do you see that this, right, it's simplified to 2 sine 4x. So you have to think about what that graph would look like. The normal graph, right, the original graph, y is equal to sine x, it goes from 0 to 180 degrees. Now, they say from 0 to 90 degrees. We're going to have to understand what that means for this graph. So the original graph goes from 0 to 180 degrees. But now because the graph is y is equal to sine 2 sine 4x, right? Because that's your graph now. You're going to have to think about what that 4 does to this graph. The 4 is going to make your graph more narrow, okay? So it's not going to finish a cycle now in 360 degrees anymore. It's going to finish a cycle in 360 degrees divided by 4, which is in 90 degrees, which makes perfect sense. That's why they said where x is an element of 0 to 90 degrees. So you're still going to have a full sine graph, right? Where the maximum, because you see that 2 is the coefficient of sine, right? The maximum is 2 and the minimum is negative 2. But now these angles are a little different. Your new period is 90 degrees. That's why they said x is an element of 0 to 90 degrees, because it's going from 0 now to 90 degrees. It will finish one cycle like that. What they're asking us for is for which values of x, right, in that interval will this graph have a minimum value. So where is the minimum value? What is the x value that belongs to that minimum value in this graph right now? We can see that there's a maximum here, and so this makes this a minimum. Think about what all the angles are doing. You know now that they're all going to divide by 4. So what happens here is before, right, when we didn't have this 4 here, the normal sine graph, at this point where it's equal to -2 or -1 actually, because that's the original sine graph, the x value over here would have been 270 degrees. That's what it would have been, okay, because of the way it usually goes. It goes 0, then this is 90 degrees at 1, and then 180 degrees at 0, 270 degrees at -1, which is -2 right now, of course, because of that 2 that's been put in front of the sine, and then 360 degrees here, okay? So all these angles, all the answers that you used to have, they are just going to be divided by 4. So it's 270 degrees divided by 4, and that's where that minimum is going to happen. So you can tell them that the minimum x value is that x is equal to, and just show them it's 270 degrees divided by 4, and then we just find out what exactly that is, which, as we can see, is 67.5 degrees. So that is at 67.5 degrees. That's what that minimum is going to be, the x value, that minimum. Okay, so there we go. As you can see, that's a 1-mark question. It's not something that we had to do that for. I just put the graph so that I could explain that. Okay, so that is it for question 5. And then we move on to question 6 with more trigonometry. We are now on question 6, and question 6 says, in the diagram below, the graphs of f of x is equal to tan of x and g of x is equal to 2 sine 2x are drawn for the interval where x is an element of -180 degrees to 180 degrees. Then they tell us that A, 60 degrees and K, which is over there, and B are 2 points of intersection of the graph of F and G, as we can see. Okay, so the first question is to write down the period of G. Okay, so to find the period of a graph, you're always just going to think about what the original period would have been if it was not manipulated in any way. So the graph of G, when we look at that, you can see that it's a sine graph because it's 2 sine 2x, right? So think about what the original sine graph's period is. The original sine graph, this graph, it has a period of 360 degrees because it takes 360 degrees to complete one cycle. So every time it repeats this same pattern again, it's just completing another cycle. Okay, so that's another cycle that it completed. So the original sine graph takes 360 degrees to complete a cycle, and then you're going to take that amount and you're going to divide it by whatever is in front of your angle, because that is what is going to alter the period. That's what's going to change the period. So the number in front of x is 2. So we're going to divide this by 2. So if you divide that by 2, it gives you 180 degrees. So it means that this graph's period is 180 degrees, and that would be our answer. Moving on to the next question. The next question, 6.2.1, says calculate the value of k. Okay, so where is k? K is over here. So if this is K, okay, this is not a complicated one. You see that they gave you your graphs. They didn't hide anything in the graph. So to find this, you can already see that the x value is 60 degrees. Since this is A, because it can't be this is 90 degrees. So since this is A, just substitute the x value of 60 degrees to find the y value, which would be K's value. So substitute it in any of these graphs because this is a point of intersection. So we can use the tan graph because it's easier. You can simply just tell them that K would be found by saying tan of 60 degrees. And then find out what tan of 60 degrees is. Okay, so K is equal to, and tan of 60 is the square root of 3. So that is our answer. K is equal to square root of 3. Moving on to the next question. Next question, 6.2.2, says calculate the coordinates of B. So B is over here. Okay, so this is how you need to be looking at these graphs and just seeing how they repeat themselves. You see, with this first graph, this sine graph, right, g of x is equal to 2 sine 2x, you can see that we know now that this graph will complete a cycle within 180 degrees since the period has been changed. So we know that this is one cycle, right? And here it's completing another cycle, also in 180 degrees. So how we would find B is by actually looking at where B is. Do you see that over here, right, where we had this? because these two graphs intersect here, where in the positive part of where y is positive, really, they're going to intersect again 180 degrees before this, and that's over here. So to find out what exactly that point is, do you see that if it's 180 degrees before this, the only thing changing, we are moving to the left, the only thing changing is the x value. That y value is going to stay exactly the same. So we already know it's the square root of 3. So it means that this will just be 180 degrees backwards, which is minus 180 degrees. So you take it from where it is, it's at 60 degrees, and you say minus 180 degrees, and you'll find that. Okay, so that's all we're going to do there. What is 60 degrees minus 180 degrees? And that is negative 120 degrees. So it means that point B is actually negative 120 degrees, and the K value was square root of 3. So that is our point, negative 120 degrees and square root of 3. And see, that makes perfect sense. Negative 90, negative 120, and then negative 180. Okay, so we know what these points are. We know this is square root of 3 as well. Okay, so that is it for that question, and we move on to the next question. The next question, 6.3, says write down the range of 2g of x. Okay, so they are already changing it. So think about what g of x already is. G of x, they told us, was equal to 2 sine 2x. But now they put in a 2 in front of that. So that just gets multiplied by 2. So 2g of x is times 2, which is 4 sine 2x. Okay, so the range, think about what the range of the normal sine graph is. Normal sine graph, despite the fact that the period has been changed, the sine graph always goes from, or the highest point it will reach normally is 1, and then the lowest point is negative 1. So because the coefficient of sine, right, is now 4, it means it's going to go up to 4, and the lowest would be negative 4. So it's y is an element of, and you see because it goes up to 4, so the lowest value would be negative 4 and the highest would be 4. And of course we're using square brackets because at these points, at these y values, negative 4 and 4, you're going to have actual points that have these y values. So we use square brackets. So that is the answer over there. You could have also chosen to write this in set builder. So there you will say y is greater than or equal to negative 4, because that's really what it's doing. It's going from negative 4 to positive 4. So the lowest value is negative 4, meaning y is greater than or equal to negative 4, but less than or equal to 4. So that's another way that you could have written that. So that is the answer to that question. Moving on to the next question. We're on 6.4, and 6.4 says, for which values of x will g of x plus 5 degrees minus f of x plus 5 degrees be less than or equal to 0 in the interval where x is an element of negative 90 degrees to 0 degrees? Okay, let's break this down. First of all, let's take the inequality they gave us. You see that they're saying g of x minus f of x must be less than or equal to 0. It would be complicated to have to think about it like that, like trying to take g of x minus f of x and then trying to see, is that space going to be less than or equal to 0? Okay, so what we're going to do is rather take that equation and we will take negative f of x plus 5 degrees over to make it positive. So what we have is g of x plus 5 degrees and then is less than or equal to positive f of x plus 5 degrees. Okay, so that looks simpler now. So we can just focus on where the graph of g is less than or equal to the graph of f. I see that we have plus 5 degrees, but let's consider that at the end to not complicate things. Okay, so we also know that this should be within the interval of negative 90 to 0 degrees. Okay, so let's go ahead and look at this graph. Okay, so right now we don't really need these colors anymore. When we are looking for where g of x, right, because we're just really looking for where g of x would be less than or equal to f of x. We're not really considering the 5 degrees yet. Let's look at it like this. So when you're asking yourself this question, because you can see that g of x is less than or equal to f of x, what you should be looking for is where the graph of g is below the graph of f. Of course, within that interval they spoke about. They told us that the interval was between negative 90 to 0 degrees. So we're only going to look within this interval. So within this interval, where is G, the graph of G, lower than the graph of F? You see that over here, the graph of G is higher than the graph of F, all through here, right? And then they intersect at this point. Then the graph of G is now below the graph of F. And that's what we're looking for. We're looking for this place, this. Okay, and we're going to tell them exactly what the X value is. And then, of course, after that, it becomes above the graph of F. But that doesn't matter because we're looking within this interval. Okay, so to be able to actually find this, because we know it is now, it's just find what exactly this is, and we'll know that this is happening between this degrees all the way to that degrees. Okay, we will still apply the 5 degrees shift that we saw. So let's find out what exactly this is. What is that? Okay, so you have to think about how the sine graph behaves and the tan graph really. So with these graphs, they're very repetitive. They do the exact same thing over and over again. If you look at the sine graph on this side, do you see that from 0 degrees all the way to this point over here, okay, that it is 60 degrees. And this is a significant point because at this point, this is the point where the graph of F intersects the graph of G. Now, if you look on the left-hand side, do you see that the graph of F and the graph of G intersect again? So remember, these graphs are symmetrical, right? The way they behave, they really just do the exact same thing. So meaning, you see this part, right? This part, it's doing the exact same thing as this part. If you just took this and you turned it around, it would fit perfectly on this. So we can do that. You see, if you take this and we turn it around and then you put it here, do you see that it's going to fit perfectly on this? So that would mean that when this line, right, that we drew, when it was originally here, it went from 0 degrees and it took exactly 60 degrees later for it to intersect with the graph of F. So if we were moving to the left, how much degrees would we have to move for it to intersect again with the graph of F? It would also be 60 degrees. So if you move 60 degrees to the left, it's going to intersect with the graph of F over there. So that's what's going on there. This happens at negative 60 degrees on this current graph that we have here. Okay, so now we know what exactly that point is. And now we know that for this, right, not considering the 5 degree shift yet. Now looking at this, we know that this is going to happen where g of x is going to be less than or equal to f of x. It's going to happen where x is greater than, because you see that it happens all through here. This is where the graph of g is below the graph of f. So this is where x is greater than or equal to, because we have to consider equal to as well, negative 60 degrees, but less than or equal to 0 degrees. And of course, they intersect again at 0. So that would solve this question. But our question specifically said g of x plus 5 degrees is less than or equal to f of x plus 5 degrees. So we have to consider that shift. So you see a plus and then it's adding to an x value. When you're adding to an x value, you're actually shifting to the left, not the right. When we're minusing from an x value, then we are shifting to the right. So it really just means that this answer that we had, or really these graphs that we have here, they would have been shifted to the left by 5 degrees. So this wouldn't be negative 60 degrees anymore. It would be negative 60 degrees and then move 5 degrees to the left, which would be negative 65 degrees. And this wouldn't be 0 anymore. It would be 0 degrees, but go 5 degrees to the left, which is negative 5 degrees. So really, these graphs, they would just shift from where they currently are. So all we're going to do is replace the negative 60 and the 0 degrees. So that means our answer would be x needs to be greater or equal to negative 65 degrees, but less than or equal to negative 5 degrees. And that is our answer. Okay, so that is it for that question. And we move on to the next question. Okay, 6.5 says, determine the values of p for which sine x times cos x is equal to p will have exactly 2 real roots in the interval, negative 180 degrees to positive 180 degrees. Okay, since we know which interval it's from, and well, you just know that they're not going to give you a brand new graph, okay? So this graph definitely relates to something that you already had. And already looking at sine x cos x, it probably has to do with the graph of g, because remember that g of x is equal to 2 sine 2x, right? And as you can see from that sine 2x, that is double angles that we have there. So we can expand that using the correct double angle expansion for that. Okay, so we can start from there. So that is going to be, we have g of x is equal to, and this is 2 first outside, but then this, the expansion for that is 2 sine x cos x. So do you see now that what we have is 4 sine x cos x? Okay, a lot like what they have, but they have is equal to p. Okay, so we know that they're using the graph of g, and they want us to have exactly 2 real roots within that interval. So from negative 180 to positive 180. If you look at this graph right now, okay, remember when you're trying to find the roots, you're trying to find the x-intercepts, okay? So make y equal to 0. So we can really just look at this as 0 is equal to, and then we have this so long. So let's try to understand how they can have exactly 2 real roots by looking at the amount of roots that they currently have. So the graph, remember, we're only focusing on the graph of g, the sine graph. So that is this graph, and we can just highlight it so we can control it. We needed to have 2 real roots, exactly 2 roots. So count the amount of x-intercepts that you have. How many roots do you have? It has an x-intercept over there, 1, 2, 3, 4, and 5, okay? Intersects the x-axis 5 times. We want it to intersect only twice. So let's think about how this graph should be shifted. You can shift it, of course, if you shift it left or right, it's not going to change anything. It still has the same amount of intercepts, okay, x-intercepts. However, if you shift it up, look at what happens. If you shift it up to the point where the minimum values, right, where that minimum is supposed to be, is sitting on the x-axis, then you have exactly 2 x-intercepts. You have 1 over here and 1 over here. Done. And that's what they want. Okay, now, as you can see, that's not the only way that we can do that. We can either shift it up, or if it was still exactly where it was, what we could do is shift it down. So shift it down until it hits the x-axis like that. And then it has 2 x-intercepts as well. So you can see that there are 2 options, but now we have to find out how far we're shifting it. When it was here initially, how far did you shift it so that it can look like this? We can actually see how far we need to shift it. So thinking about what the lowest values were, you see that the minimum here, right, because this is 2 sine 2x, meaning the lowest it's going to reach is negative 2, and the highest it will reach would be 2. Okay, so that is the original graph. The highest it will be 2. So it means that for you to have shifted it from where it was to get it to this point, this is shifting it up first, you must have moved it, okay, from negative 2, and then now you moved it until that is no longer at negative 2, but is at 0. So you shifted it 2 units up. Okay, so we know that moves 2 units up. And of course, when we're looking at the graph, shifting it down also works, right? So if it was here originally, and you needed to move it down, you would shift it how many units down so that it can have exactly 2 roots. You would shift it exactly 2 units down, since the highest is at 2 and you want that highest to now sit on the x-axis to be at 0. So you moved it from 2 to 0, meaning 2 units down. So we know exactly how we need to shift these graphs. Okay, so remember how we still have this? So what I'm saying is we're going to shift those graphs 2 units up or 2 units down, and it should work out fine. So we're taking the graph that is the original g of x, it just looks like this right now, for sine x cos x, and if you shift it 2 units up, this will help it to have 2 x-intercepts. So you'll see how this will act as the p-value. So we're still focused on this equation, but shifting it 2 units up. Or the second option is to take this graph for sine x cos x and then shift it down by 2 units. Minus 2 is equal to 0. And now we can just solve. So at the end of the day, we need to find out what p is. So get the equation to look like this. Sine x cos x. Okay, right now it's 4 sine x cos x and then plus 2. So let's just simplify. We can take the 2 over. So that's 4 sine x cos x is equal to negative 2. Then divide both hand sides by 4 to get rid of that 4 because you need it to be sine x cos x. So right now we have sine x cos x is equal to negative 1 over 2. Or, and then over here we have 4 sine x cos x is equal to 2. And then divide both hand sides by 4 to get rid of the 4. And then sine x cos x is equal to positive a half. Do you see the two values of p, or that p can be, for them to have exactly 2 roots? So p should either be equal to negative a half or p should be equal to positive a half. And that is our answer. Okay, so that is it for the graph section of trigonometry. And then we go on to 2 and 3D trigonometry, which is in question 7. So we are on the last section of this paper. And it's the last section because the Euclidean geometry section is already uploaded. So I'm just going to compile them into a playlist so that the November 2022 grade 12 exam paper 2 is there. Okay, so we are on question 7, which is the 2 and 3D trigonometry section of this paper. And this is what we have. Question 7, AB is a vertical flagpole that is the square root of 5p meters long. So these are all in meters. Then they tell us that AC and AD are 2 cables anchoring the flagpole. Okay. B, C, and D are in the same horizontal plane. And then we are told that BD, as we can see, is 2p meters, and angle ACD is x, and lastly angle ADC is 45 degrees, like we can see over there. Okay, so the first question is to determine the length of AD in terms of p. Okay, so let's just see where AD is. AD is over here. So if this is AD, how do we find the length of this? Well, you see that we have a right angle triangle. We don't have any angle in here because you see this 45 degrees here. It doesn't belong to this angle. It's this angle. So all we have right now is a right angle triangle. Do you see that in this right angle triangle, we have been given this side AB and this side 2p. So we can clearly use Pythagoras. So we can use the theorem of Pythagoras to find AD. Okay, let's go ahead and do that. Okay, so our formula is going to be AD squared is equal to, and we're going to take that shorter side squared, so that is 5p. We're going to just say 5 square root of p and then square that. And because it's the longer side, you're going to add the 2 other shorter sides. So that's 2p squared. So 2p, and we of course square it. Okay, so let's just go ahead and solve for AD. So AD squared is equal to, this would give us, sorry about that, that is not 5p, that is square root of 5p. Okay, so this would give us, if you square a square root, it breaks open, and so you have 5 and p squared plus 4 and p squared. So these are like terms, we can add them together, meaning AD is equal to 9p squared. Okay, so to find AD, we square root both sides, and therefore AD is equal to 3p. And there we go. Okay, so that is the first question. Moving on to the next question. The next question, 7.2, says, show that the length of CD is this. Okay, notice that there are only x's in here, but we'll just see. We'll see how we can come about that. Okay, so remember that we just found AD, right? So we should put that down. That would probably be helpful. So that's 3p. And they want us to find CD. Now, CD is over here. How can we find this length? Well, clearly we can't find it using this bottom triangle because we have literally no information here, nothing here. So that is already out of the picture. So what else can we use to find CD? Well, we can use this triangle. So in this triangle, what we just found is this AD. We found what AD is. And the other thing that we know in this triangle are some angles. So we've got the angle X. We've also got the angle 45 degrees. So that's very helpful. So what rule can we actually apply to this to find CD? This looks like the sine rule, okay? So with the sine rule, if you're looking for a side, then you need to have the angle opposite that side present. So right now we don't have anything, but we can actually find this because we've got X and we've got 45 degrees. So we can actually find that. Okay, so we're going to use that to find that angle, angle A, and then what or which angle and side can we pair up to use to find CD? Do you see that we have in this triangle this X, right? This is what we already have. We don't have to look for that. It has a value, X. And you see that opposite the X, you've got 3P. So those are the sides we can use. We can use AD and we can use the angle opposite AD. And then, of course, we can use CD because we have to. It's what we're looking for. And then we can use the angle opposite CD. Okay, let's go ahead and do that. Okay, so of course, doing that, you see that the only thing that was missing was this. So we need to find this. Okay, we can. It's a triangle, and you know that the interior angles of a triangle add up to 180 degrees. So to find this angle, we'll just say 180 degrees minus X and minus 45 degrees. Okay, so that's what we can do. We can start off with angle A and say this is equal to 180 degrees minus, we can just say 45 degrees minus X. And so this is going to be 135 degrees minus X. That's what A is. So we can put that down. That is 135 degrees minus X. Okay, now we can go ahead and use the sine rule. So we're looking for CD. And so we're going to take CD over sine of this angle. And then you also have, because you started with a side and then an angle, you need to also start with a side and angle for the next pair. So we will take AD, which is 3P currently, over sine of that angle. And that will be the sine rule. Okay, let's go ahead and put that down. So we are saying first CD over sine of the angle we just found, 135 degrees minus X. And then this is equal to AD, which is 3P, over sine of that angle X. Okay, and all we have to do now is make CD the subject. So you see that to make CD the subject, you can just get rid of this denominator. So to get rid of that, we can just use the multiplicative inverse. Okay, so you're just multiplying both sides by sine 135 degrees minus X to get rid of that. So it's an equation. What you do on the one side, you must do on the other side. So now that that's done, these two cancel and you're left with CD is equal to, and on the numerator, we have 3P times sine 135 degrees minus X all over sine X. Okay, so this is what we have. And let's just see. Okay, it doesn't really look like what we have yet. So there's clearly some more simplifying that we need to do. But you see that we are on the right track because you see we have sine X, we've got sine X as well. We've got 3P here, we also have 3P here. So we just need to simplify that. That's all. Okay, let's see. We can actually break this up. So you see we have CD is equal to 3P. Okay, so when looking at the angle 135 degrees, it is not over 360 degrees. So, you're not trying to get it back to that. However, we can reduce it. Okay, so you can reduce it. But straight away, we could already see that this angle has 90 degrees in it and then an acute angle. Here's what I mean. So we can break it up. We can say this is equal to 3P and we have sine. And now what this is if you break it up into 90 degrees and the other angle that you have, you're going to have 90 degrees plus what angle gives you 135 degrees plus 45 degrees. Okay, so remember, we are not changing anything. We are just changing the way it looks, but it still has the same value. Okay, 90 plus 45 is 135, and then minus x. So we can actually use cofunctions here. If we group these two together like that, so grouping those together, we can use cofunctions, and it's possible to do so because you see we have a plus sign. There's no confusion with that. Okay, so we're just grouping those together. So over, and we have sine x. And then CD is equal to, we have 3p. And then with this, you see, this is sine 90 degrees plus an angle. So you see how this gives you cos A. In the same way, sine 90 degrees plus 45 degrees minus x is now going to give you, you can just view the A as if it's a 45 degrees minus x. So it's just going to give you cos 45 degrees minus x. Okay, that's what we have there. And then all over sine x. Okay, so we clearly have to expand that more. So we can just use one of the compound angle expansion for that. Okay, because we can't reduce it, we can't use cofunctions on it, it's 45 degrees. So we'll just say 3p, and then let's expand. We have cos of a first angle minus the second angle. So this is going to be cos of that first angle, 45 degrees, times cos of the second angle, x. And then because it's a minus, that changes to a plus, according to the compound angle rule for cos. So we have now sine 45 degrees and sine x all over sine x. Okay, this is good because these are special angles and we can actually expand those. Now, I would always say this because I have seen this happen in the past where your answer ends up not looking like what they told you it should look like. In this situation, they already gave you the answer. And the reason it doesn't look like that in this type of question was because you didn't stick to the rule of do not use a calculator for these types of calculations. So if you use a calculator, your answer would look slightly different. So instead of using a calculator for these cos 45 and sine 45, I'm going to use the OHA rule. So the OHA rule is meant for special angles and it works for all the angles. Any other angle that is not included in the OHA rule, you can just use the calculator. It would give you the exact same answer it's supposed to give you if you had used the circle, the trig circle, you know, with the different triangles that you form and then the different sides, or the triangles, the 3 triangles that you maybe would have memorized. So those are for special angles, but you can't just use the OHA rule. We say OHA, OHA, and then you say 30 degrees, 60 degrees, and 45 degrees. Then you say 1, 2, 3, 3, 2, 1, 1, 2, 1. Then in each of these rows, you're going to square root the biggest number, not angle, number. Okay, so we square root the 3 here. Here we will square root the 3. And here we will square root the 2. And so to find cos of 45 degrees, we'll say cos, we know from saw, katoa, that cos is adjacent over hypotenuse. So we're going to go to 45 degrees, the 45 degrees row, and we're going to take the adjacent, which is a 1, over the hypotenuse, which is the square root of 2. And you also see that sine of 45 degrees will give you the same thing. That's saw, sine is opposite over hypotenuse. So that is at 45 degrees, opposite is 1 again over hypotenuse square root 2. Okay, so you see that it is 1 over square root 2 that we would get for both of them. So this is how this expands. We say CD is equal to, we have 3p, and then that gives you, it's going to give us 1 over square root 2. So we have 1 over square root 2 multiplied by cos x, right? And then plus 1 over square root 2 multiplied by sine x. Okay, all over sine x. Now, what you could do at this point is just take out the 1 over 2 as a common factor from this bracket. And so we'll have CD is equal to, and that common factor will just go in front of the 3p, okay, the 3p. So it's multiplied by 1 over root 2. Now I'm writing it like this for a reason, because that it is a fraction. You see the 1 is going to go with the 3p, and then that is a denominator. So it looks like that. And then in the bracket, what you're going to have is your cos x plus your sine x, which makes perfect sense. That's why they had that. They had sine x plus cos x. Okay, so we can also just put the sine before the cos. And then we have all over sine x. Now, you can put it as all over sine x, but it really just goes here. It's all over sine x, okay, because these two would multiply. Here's a quick explanation of that. The sine x is being divided by everything here. Okay, so if you're dividing by sine x, what happens is you're saying divided by sine x, but you have to make sine x a fraction so that it can work with these, because that has a fraction. So over 1. And of course, you would tip in times. So CD is equal to, and what happens here is you have these two multiply. Actually, all of these multiply because they're in the numerator. So you have 3p times, and we'll just say sine x plus cos x, changing the order of that. So it looks like our answer. And then over the square root of 2. Now, what happens with this is you tip in times. So you swap the numerator and the denominator. So they look like this now. And you see what happens when you multiply numerator and denominator. CD is finally equal to 3p multiplied by sine x plus cos x all over, and those two multiply to give you square root of 2 sine x. Just like they said it would be equal to. Okay, so that was their answer as well. Okay, so that is it for 7.2, and we move on to the last question, 7.3. The last question, 7.3, says, if it is further given that p equals 10 and x equals 110 degrees, calculate the area of triangle ADC. Okay, let's go ahead and see the triangle ADC. Okay, we don't need any of these anymore, really. Area of triangle ADC. So this is triangle ADC. And to find the area of this triangle, as you can see, it's not a triangle with a perpendicular height. So because it's not that, we're going to use the area rule. With the area rule, you need one focus angle and you need two sides available. Right now, we actually have that. Remember, we found CD and we found AD as well. So we can use CD, AD, and the middle angle, 45 degrees. Okay, so we're just going to go ahead and use that. Okay, just keep in mind this was 3p. This we found CD. Okay, it's that long thing, but we'll include it. And we're going to just use this as a half times AD times CD sine of that center angle, angle D. Okay, so this is what we have. And now we can just substitute. So the area of this triangle is equal to a half times AD, which we know is 3p, right? Multiplied by CD, which we know is that. So we can just take that and substitute it there. And then, of course, sine 45 degrees. So sine 45 degrees. And they told us that p is equal to 10 and x is equal to 110 degrees. So just substitute. So this is a half. I'll just leave it like that. So a half multiplied by 3p. So that's 10 times 3. You see, it's just substituting at this point. And then sine of 110 degrees plus cos 110 degrees. So that's together. Cos 110 degrees. Then lastly, we just have over the square root of 2 sine x, which is 110 degrees again. And then lastly, we have sine 45 degrees. And you can just nicely substitute that onto the calculator and see what you get as an answer. Okay, and really these two were in brackets. Okay, so just don't forget to put that. Okay, so our answer is 143 point, and you see that 6 is going to round up, so 0.11. And these were in, they said that flagpole was, okay, they're in meters. So 143.11 meters squared. And that is the answer. Okay, so that is it for this video. And I will also add the Euclidean geometry section, which is already up. So it's just going to be a playlist. Okay, so then after this, I will go ahead and compile the paper 2 compilations. And there we go. You guys can use that to practice with maths. All the best for your exams in future. And I hope to see you guys in the future videos. Bye.